We've already seen alcohols in many of these videos, but I thought it was about time that I actually made a video on alcohols. On alcohols. Now, alcohols is the general term for any molecule that fits the pattern, some type of functional group or chain of carbons, OH. And they use the letter R, and I've used it before. R stands for radical. And I don't want you to confuse this R with free radical. It means completely different things. R in this form really just means a functional group or a chain of carbons here. It doesn't mean a free radical. This just means it could be just, something attached to this OH right there. Now, another point of clarification. Do not think that anything that fits this pattern is drinkable. Do not associate it with the traditional alcohol that you may or may not have been exposed to. Traditional drinking alcohol is actually ethanol. Alcohol is actually, let me write out the molecular formula, CH3, CH2, and then OH. This is what is inside of wine and beer and hard liquor or whatever you might want. You do not want to drink, and maybe you might not actually want to drink this either, but you definitely do not want to drink something like methanol. It might kill you. So you do not want to do something like this. You do not want to ingest that. It might kill or blind you. This might do it in a more indirect way. So I want to get that out of the way, and just so that we get kind of a little bit more comfortable with alcohols. And we've seen them involved in other reactions. We've seen hydroxides act as nucleophiles, and SN2 substitution reactions create alcohols. But what I want to do is just learn to get comfortable and really make sure we know how to name these things. So let's just name these molecules that I drew right before I pressed record right over here. So over here, like everything else, we always want to identify the longest carbon chain. We have 1, 2, 3, 4, 5 carbons. So it's going to be pent. So it's going to be pent, and there's no double bonds. So it's a pentane. So I'll just write pentane right there. And we're not going to just write a pentane, because actually the fact that makes it's an alcohol, that takes precedence over the fact that it is an alkane. So it actually, the suffix of the word will involve the alcohol part. So it is pentanol. So let me do that. The pentanol. That tells us that it's an alcohol. And to know where the OH is grouped, we'll start numbering closest to the OH. So 1, 2, 3, 4, 5. So this, sometimes it'll be called 2-pentanol, and this is pretty clear because we only have one group here, only one OH, so we know that that is what the 2 applies to. But a lot of times, if people want to be a little bit more particular, they might write pentan 2-ol. 2-ol. And this way is more useful, especially if you have multiple functional groups, so you know exactly where they sit. This one is harder to say. 2-pentanol is pretty straightforward. Now let's try to name this beast right over here. So we have a couple of things going on. This is an alkyne. It is an alkyne. We have a triple bond. It's an alkyne. We have 2 bromo groups here, and it's also an alcohol. An alcohol takes precedence on all of them. So we want to start numbering closest to the alcohol. So we want to start numbering from this end of the carbon chain. And we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this is going to be, this is an we want to call it an octyne, but because we have an alcohol there, we want to call this an octyne. Let me make it very clear. So oct tells us that we have 8 carbons. Now we have to specify where that triple bond is. The triple bond is on the 5 carbon. You always specify the lower number out between of the carbons on that triple bond. So it is oct 5 5-ine. That tells us that's where the triple bond is. And then we have the OH on the 4 carbons. So 4, 4, 4, all. And now we have these 2 bromo groups here on the 7 carbon. So it's 7, 7 dibromo, oct 5-ine 4 all. And this would all be one word. Let me make sure that you realize that this should be connected. I just ran out of space. So that's probably about as messy of a thing you'll have to name, but just showing you that these things can be named. Now let's think about this one over here in green. So we have 1, 2, 3, 4, 5, 6 carbons. So it's going to be a hex, and it's actually, and there's all single bonds. So it's a hexane, it's a cyclohexane. But then, of course, the hydroxide, or the hydroxy group, I should call it, takes dominance. So it's a hexanol. So this is a cyclohexanol. And once again, that comes from the OH right there. And you don't have to number it, because no matter what carbon it's on the same one. If you had more than one of these OH groups, then we would have to worry about numbering them. Now let's just do this one right over here. So once again, what is our carbon chain? We have 1, 2, 3 carbons, and we have the hydroxy group attached to the 1 and the 3 carbon. So this is going to be, prop is our prefix. It is an alkane. So we would call this, and there's a couple of ways to do this. We could call this 1, 3 propane propanediol. Actually, I don't have to put a dash there. Propanediol. And over here we would have the E because we have the D right there. So it's propanediol. If it wasn't diol, it would be propanol. You wouldn't have the E, D, and the I there. So this would specify where at the 1 and the 3 carbons we have the hydroxy group. Or this could also be written as propane 1,3 diol. And once again, the di is telling us that we have 2 of the hydroxy groups attached to this thing. But either of these things are ways that you would see this molecule named.